Hello viewers, welcome back to my channel. Let us continue that our topic is about the radical axis. Okay, so already we discussed about the radical axis. So for the given two circles, S is equals to 0 and S dash is equals to 0, the locus point whose length of the tangent to the two circles is equal, that is the length of the tangent which is drawn from the P to the first circle and to the second circle is PA is equals to PB, right or not? So by simplifying this one, so this length of tangent root S11 to the first circle is equals to root S11 to the second circle. Okay, then the location will get a line. This line is the radical axis. Okay, yes, then how we are going to get the radical axis of S is equals to 0 and S dash is equals to 0 is S minus S dash is equals to 0. Yes, so it is already we discussed from the last video. Yes, then after we discussed about the properties of the radical axis also. Yes, so what is the properties of the radical axis is? So C1 is the center of the first circle, C2 is the center of the second circle. Radical axis is always perpendicular to the line joining of the centers of the two circles. Yes, so what is the first property is the radical axis is always perpendicular to, right? So it is the line joining of the centers C1 and C2. That is the first thing. And the radical axis is always bisecting the common tangent to the two circles. The radical axis is always bisecting the common tangents. Okay, yes, that is one of the important thing. Yes, and one more thing is, suppose there are the two circles, for the given that there are the two circles, S is equals to 0 and S dash is equals to 0. Okay, there is a circle which intersect the two circles, orthogonally. There is a circle which intersect the two circles. Yes, it is a third circle which is suppose S3 is equals to 0, which intersect the two circles orthogonally. Then the center of the circle which lies on the radical axis. Okay, yes, so what is this property is the locus of center of a circle which intersect the given two circles orthogonally. Okay, that means angle between the third circle to the first circle, third circle to the second circle is 90 degrees. Okay, if it is happening like this, then the locus of center of circle which lies on the radical axis. Okay, yes, and one more thing is, suppose the radical axis of the three circles whose centers are non-collinear. So there are the three circles, circle 1, circle 2 and circle 3. So whose centers are not collinear, C1, C2 and C3. Right, C1, C2, C3, the centers of the three circles which are non-collinear. Then the radical axis of the three circles. Okay, yes, let us see the radical axis of 1 and 2, it will be like this. The radical axis of C1 and C3 will be like this. The radical axis of C2 and C3 will be like this. These three are intersecting at a point. That means I can say radical axis of the three circles whose centers are non-collinear. These radical axes are concurrent. These radical axes are meet at a point concurrent. Then that particular point is called radical center. Yes, what it is? Radical center. Yes, what is the definition of a radical center? The point of intersection of radical axis of the three circles. So which is called a radical center. Okay, yes. So let us discuss some more properties about that radical axis and the problems which are related to that radical axis. Okay, yes, just wait. Yeah, so radical center which already discussed. Okay, so what is the radical center? So the point of intersection of, right, the point of intersection of radical axis, okay, radical axis of three circles, right, or not? Radical axis of the three circles whose centers are non-collinear, right, or not? Whose centers are non-collinear. Okay, let us say some properties about this one. Okay, so let us take the three circles whose centers are non-collinear. So C1 is the center of the first circle, C2 and C3, right. So this is the radical axis of the first circle, radical axis of the second circle, radical axis of the third circle. Okay, so they are concurrent at a point P. Okay, so that point P is called the radical center, right, and radical center. Okay, here, so one of the very important thing is, right, so if the centers of the three circles are non-collinear, what is the equation of the circle? Very important condition. What is the equation of the circle which intersect the three circles orthogonally? There is a one more circle, there is a one more circle, so which intersect the three circles orthogonally. So what is the condition for this one? Which intersect the first circle, second circle and the third circle, intersect the orthogonally. For that circle, this is the radical center. Radical center is the center of the required circle. So what is the required circle? Which intersect the given three circles orthogonally, right or not? And what is the radius of this one? So what is the radius of the required circle is the, yes, come on, please observe this one. So here if you are observing this one, so what do you say it is? This is the, this is radical center, let us take P, and PA or PB or PC, whatever it is. So what I have drawn this one, this is the radius of the required circle. At the same time, this is the PA and PB and PC are the length of tangents. Am I right or not? Length of tangents from the radical center to any of the circle. Okay, not? So it is PA or PB or PC is the length of tangent. Okay, so which is the length of tangent from the radical center, right, and from the radical center. Like this, we will get this, the equation of the required circle. Yes, what is the condition for this required circle is the which intersect the three circles, which intersect the three circles orthogonally. Then the radical center is the center of the required circle. This radical center becomes the center of the required circle. And so what is the radius of the required circle is the length of tangent, which is from the radical center to any of the three circles. It may be PA or it may be PB and it may be PC. Okay, Nat? So one of the very important model, right? Come on students, make a note and we will discuss some conditions about that radical center. Yeah. So let us discuss some properties about the radical center in different cases. Of those, the first case is, so for the triangle ABC, I am going to draw the three circles, okay, whose centers are, okay, whose diameter is the sides of the triangle, right, means the center, these are all the centers, exactly the midpoints of the sides. I mean how I am going to take the circles, so whose diameters are the sides of the triangle. Okay, so here I am going to take the triangle, circle will be like this, okay, and this will be the second circle and this will be the third circle, right. So how I can draw the three circles whose diameters are the sides of a triangle. Okay, in that case, so all these are the intersecting, yes, for radius and radical axis and radical axis. In that case, what is the condition for the radical center? Okay, yes, in this case the radical center P is the orthocenter, yes, orthocenter of the triangle ABC. Yes, so how it will be the orthocenter? Yes, let us discuss this one. Okay. So anyway, this will be the radical axis. So here I can get the radical axis, right or not? So, and we know one condition, radical axis is always perpendicular to, is it right or not? Radical axis is always perpendicular to the line joining of centers of the two circles, right or not? And at the same time, C1, C3 is parallel to the side BC. So, we discussed that one already. The line joining of centers of two circles is parallel to the third side. The midpoints of the sides of a triangle is parallel to the third side and its length is half of the third side. School level concept. Okay. That means, if this radical axis is perpendicular to the C1, C3, means this radical axis is perpendicular to BC also. So, I can say radical axis is perpendicular to the side BC. Of course, the same thing I can say radical axis is perpendicular to AC also, radical axis is perpendicular to AB. Of course, this radical axis becomes the altitude for the triangle ABC. So, what is the point of intersection of altitudes is nothing but orthocenter. At the same time, this is the radical center of the three radical axis, right or not? Yeah. That is the first case. Yes, what is the first case? So, circles are drawn whose diameters are the sides of a triangle. In that case, radical center is the orthocenter. Okay, not? And at the same time, I can discuss one more point also. If the three circles are intersect orthogonally, then radical center is the orthocenter. Okay, yes, come on, let us see. And one more thing is the second point. So, if the three circles touch each other, right, how it will be? If the three circles touch each other, okay, center of the first circle, second circle and the third circle, right. So, C1, C2, C3, by joining this one, you will get a triangle and this will be the radical axis and this one, this P is the, this point P is the radical center. Yes, in this case, the radical center becomes, it is the in center, right, in center of the triangle C1, C2 and C3. Suppose that ABC triangle are C1, C2, C3. How can you say it is the in center? Okay, yes, and it is the radical center, okay. Right, and this is anyway radical center is the perpendicular, this is the perpendicular, and what do you say, this length is the, what do you say, this length is length of tangent, it should be equal. I can say it is A and B and C. So, if you are going to draw this one, so here you will get the circle, this will be the in circle. Okay, yes, length of tangent from the radical center to the circle is same and it is anyway already perpendicular. So, this radical axis is perpendicular to C1, C2, okay. So, which is the in radius, PA and PB and PC are the in radius, okay. So, now the point P is the in circle, okay. Yes, the point P is the in center of the triangle C1, C2 and C3, okay. And at the same time, and one more condition, suppose if the three circles which are present exterior to each other, so three circles, yes, like this. So, A is the center of the first circle, B is the center of the second circle, C, right. So, for the triangle ABC, in this case, so what will be the radical center of the three circles, and this becomes, what is the point for the triangle ABC? Yes, come on, this will be the radical axis, right, and it is the radical center. Yes, what is the radical center for the triangle ABC? It becomes, right, what can you say, this line is the radical axis, okay, it is very clear, radical axis and it is radical center, this is perpendicular to line joining of the center, am I right or not? Radical axis is always perpendicular to line joining of the center, yes, it is perpendicular and it is also perpendicular. Then what do you say, it is the perpendicular bisector of the chord. The radical axis becomes perpendicular bisector of the triangle ABC. Then what do you say? This radical center is the circumcenter. Okay, circumcenter of the triangle ABC. Okay, yes, these are all the three different cases for the radical center. In the three different cases, yes, let us see that, observe that what are the positions of the circles in the three cases. In one case P becomes orthocenter, radical center, in this case circumcenter, and one more case which touch each other, and that case P becomes in center of the triangle ABC. So, very important concept in the objective point of view. Yes, come on students, make a note. Yeah, and one more case, a line, a circle S is equals to 0 and a line L is equals to 0 intersect at the 2 points A and B, right. So, what are the family of the circles? What are the family of the circles which are passing through point of intersection of S is equals to 0 and L is equals to 0? We have already discussed the general form is S plus lambda L equals to 0. Right, family of the circles which are passing through the point of intersection of S is equals to 0 and L is equals to 0 is S plus lambda L is equals to 0. Yes, and to get the lambda value here they may ask some different questions. Yes, where AB as diameter, AB as diameter, right, and what is the family of the circles which are passing through point of intersection of S is equals to 0 and L is equals to 0, where AB as diameter. Okay. In that case, how can you take this one? That means the center of the required circle lies on this line. Okay, that lies on this line. Then you can get the lambda value. Then after substituting in this one, have you got that model? The line and circle intersect at the 2 points A and B. What are the family of the circles which are passing through the point of intersection of S is equals to 0 and L is equals to 0 is S plus lambda L is equals to 0. And what is the condition for the required circle is that required circle, for that required circle what AB is the diameter where they are intersecting, that can be diameter of the required circle. Okay. So, that means in that case, so the center of the required circle is lies on the line L is equals to 0. Okay, this is one of the very important model. Okay, and one more thing is, so there are two circles. So, S is equals to 0 and S dash is equals to 0. Okay, yes. So, this is the S dash is equals to 0. This is S dash is equals to 0. Yes. So, the circle S is equals to 0 which bisect the circumference of the second circle. Yes, which bisects the circumference. Okay. Yes, let us see this one. This will be the second circle. Okay, which bisect the circumference of this first circle. Yes, what is the meaning of that? So, that means exactly the first circle is dividing the second circle into two equal parts, that which bisecting this one. So, A and B, this is one case. In that case, what you are going to do? That means this is the radical axis of the two circles. Yes, okay. This will be the radical axis of the two circles. S minus S dash is equals to 0. Anyway, this one. But how it is intersecting the second circle is which bisect the circumference of the second circle. That means this radical axis is the diameter. Am I right or not? This second circle is the diameter of S dash is equals to 0, which will be the diameter of this circle. Okay, not? That means the center lies on, this is C2. C2 lies on the radical axis. Okay. Sometimes they may ask the question is like this. Yes, if the circle S is equals 0 bisect the circumference of the second circle S dash is equals to 0. Of course, immediately we get the point. The point is the radical axis is the diameter of the second circle. Simply they are asking about what is the length of the common chords. What is the length of the common chord? What is the length of the radical axis where they are intersecting? Okay. Simply how we are going to calculate? Simply we are going to calculate the diameter of the second circle. Okay. Yes. Let us see some problems which are based on that. The circle bisect the circumference of the second circle. Just now I discussed, if a circle bisect the circumference of this second circle, then what is the length of the common chord? Okay. Here is this is the second circle, the first circle bisecting the circumference of the second circle. That means, so the length of the common chord is nothing but diameter of the second circle. So, okay, simply you can write like this. So, which is nothing but diameter. So, diameter of C2 second circle. So, the second circle is x square plus y square is equals to r square, radius is 1 and diameter is 2. Yes, simply 2 units. Okay, yes, and let us say same like this. So, if the circle bisect the circumference of the second circle, in that case one unknown variable, what is the k value? Right, I discussed the 2 points. If circle bisect the circumference of the second circle, so length of common chord is nothing but a diameter of the second circle. Yes, and at the same time, what you say, this is called radical axis. Okay, radical axis is always passing through center of the second circle. Right or not? Is it clear? The 2 points, right? Radical axis is passing through center of the second circle. I mean, center of the second circle lies on the radical axis. Yes, I am going to using the same point. Now, first of all, what is the radical axis of the two circles? Radical axis is s minus s dash equals to 0. So, which is 2x, okay, plus 4y, 2x plus 4y minus 1 minus k equals to 0, minus 1 minus k equals 0, which is your radical axis. Now, this radical axis is passing through center of the second circle. Yes, what is center of the second circle? Can you say? Minus 1 comma 0, no y term. Okay, yes, come on. So, x is minus 1, which is minus 2 plus 0 minus 1 minus k equals to 0. So, k equals to minus 3. Okay, yes, like this we will get the some different problems. Okay, yes, coming to the third question. BC are any 2 points on a circle x square plus y square is equals to a square. Yes, so let us take a circle x square plus y square equals to a square whose center is 0 0, right, whose center is 0 and the radius is a. Yes, come on. Now, a point A BC, the point A, I have taken that one point B comma C which lies on the circle, right. BC are any 2 points. First of all, let us take that BC are any 2 points. They mention this one like this, BC are any 2 points, right. Then the point A, so here I have taken that point A B comma C, right, B comma C lies on the circle such that AB is equals to AC is equals to D. AB is equals to AC, which is equals to D, right. So, with A as the center, can we draw a circle? With A as the center, can we draw a circle? So, this is the circle whose center is A and whose diameter is D. Can you say this one? What is the equation of the circle? So, which is x minus b whole square plus y minus c whole square is equals to d square. Here, what I am doing here, with A as the center, D is the diameter. So, I can get a circle which is passing through B and C. So, I got the circle. Then finally, what they asked, what is the equation of BC? Yes, can you say what is the equation of BC? Now, you got that the point. What is the equation of BC? Which is your common chord, nothing but a radical axis of the two circles. Already they have given that one circle and we got that another circle. Then what is the equation of the line BC is the radical axis of these two circles, which is s minus s dash is equals to 0. Okay. Yes, like this we will get the points in the board exams and in the EAMCET point of view, objective point of view. Okay. Yes, so please focus on these conditions. Okay. Yes, come on students, make a note. Yeah. Okay. So, let us say some different problems. If the two circles x square plus y square plus 2gx plus 2fy plus c is equals to 0 and x square plus y square 2g dash x plus 2f dash y is equals to 0 touch each other. Yes, so please observe this one. There is no constant term, that means both the circles are passing through origin, passing through 0 0, am I right or not? And they touch each other, that means the two circles touch each other at the point 0 0. Am I right or not? Then what is the condition? Okay, yes, one of the important thing. So, in this case, what is the center? Minus G and minus F, and second center is minus G dash and minus F dash C2. Yes, it is very clear. Both the circles are passing through origin and they have given that they touch each other. So, these two circles touch each other at 0, 0. Okay, yes, observing this one. So, what do you say about C1, C2 and the point O? They are collinear points, right? They are collinear points. Yes, you know the condition about the collinear points. Slope of OC1 is equals to slope of OC2. Just equating the slopes. Why? Because they are collinear. They give one line only. They are not different lines. Okay. So, what is the slope of? Yes, the slope of OC1 is equals to, so it is the slope of OC2. Okay. It is F by G. Okay. Yes or not? So, what is the slope of this one is the F dash by G dash. Yes, you got the condition. Okay. This is F into G dash is equals to G into F dash. That will be the condition. Okay. Yes, one of the very important condition. Yes. So, coming to the next thing, important concept in the objective point of view. What is that? Theta is the angle between the two intersecting circles whose radii are R1 and R2. Then what is the length of common chord in terms of theta, R1 and R2? Yes, let us see. So, they are intersecting circles. Come on. Yes. So, intersecting at the points P and Q. So, what do you say? This PQ is the common chord. Now, I am going to find what is the length of PQ. Okay. Yes, come on. Let us see. So, this is the center of the first circle, center of the second circle. Please join this one. Okay. Yes. So, and this line PQ is this PQ line is always perpendicular to C1, C2, and at the same time the line joining of C1, C2 which bisect the chord PQ, right or not. So, let us take this length is the M. Okay. So, come on. So, I can find this length, then after it is doubled, I can get the length of PQ. Okay, come on, let us take it is H. Suppose if it is H, the total PQ length is 2H, and this is radius R1 and radius R2. So, theta is the angle between the two circles, and what is the angle between the radii is? Angle between the two circles means nothing but angle between the tangents where they are intersecting. This will be the theta. Right or not? If theta is the angle between the two tangents at the point of intersections. Now, what is the angle between C1P and C2? Can you say? So, which is 180 minus theta. I can write angle C1P C2 is 180 minus theta. Okay? Yes. Why? Because radius is always perpendicular to the tangent. So, from the last video we discussed that angle between the two circles. Okay. Yes, come on. So, please consider the triangle C1P C2. Yes, so from the triangle C1P C2. So, I can write that area of the triangle in the two cases. So, what is the area of the triangle? Okay. Area of into base into height. Of into C1 into C2 into H. Base into height is the H is the height. Okay. At the same time, of into R1 R2 sine of angle between these two, right, and from the properties of triangles, of into R1 into R2 into angle between R1 and R2 which is sine 180 minus theta. Okay, now yes, come on, both sides of get cancel, which is H equals to R1 into R2 sine 180 minus theta is sine theta by C1 C2. Okay. Yes, please, in this case please apply the cosine rule. Okay, let us take C1 C2 is D. Okay. Yes, here I am writing this one. C1 C2 whole square is equals to R1 square plus R2 square minus 2 R1 R2 cos of angle between R1 and R2 which is 180 minus theta. Okay, net. So, cos of 180 minus theta minus cos theta of minus plus. Okay. Yes, what is the C1 C2 value? Which is root of R1 square plus R2 square plus 2 R1 R2 cos theta. This is the value of H only. Now I want the length of PQ. What do you see? Then the length of PQ is nothing but 2h. Yes, the same value, which is 2r1 r2 sin theta by root of r1 square plus r2 square plus 2r1 r2 and cos theta. Right? So one of the very important concepts. Okay. So what is the length of the common chord when the two circles are intersecting makes an angle theta whose radii are r1 and r2. Okay, here they may ask that some different questions on this one. Suppose if the angle between them is theta, of course they are orthogonally, theta becomes 90. So, okay, it is in that case 2r1 r2 sin 90 1 by denominator root of r1 square plus r2 square. Okay, now come on students, make a note. Yes, so this is about that the system of the circles. So please stay tuned to my channel. If you like this channel, I mean if you like this video, please share to your students and your friends. Okay, so be ready for the next coming video, very interesting video. Thank you for watching. Goodbye.